Okay, so we're going to continue doing probability problems, but this time you're going to be looking for certain keywords, like the words not and or. And then we're going to also look at odds, which is something different than probability. It uses probability, but gives you a little different information. Okay, so the probability of an event not occurring, the probability that an event E will not occur is equal to 1 minus the probability that it will occur. Now, we actually saw this illustrated in the expected value problems, because like in the last problem, you could either win or you lose. So if you know the probability of winning, then you just subtract that from 1, because losing is the probability of not winning, right? It's the opposite there. We saw guilty, not guilty. So either you're guilty or you're not guilty. So the probability, to find the probability of 1, you just subtract it from that total of 1. So 1 minus the probability that it does happen. So if you need a formula per se, the probability of something not happening is 1 minus the probability that it happens. Now, in some of these problems, we didn't necessarily need to know that, because like in the last one about the numbers game, if the probability of winning was 1 out of 1,000, well, we knew that there were 999 other choices, so we used the probability of losing was 999 over 1,000. But really what you were doing was, in your head, you knew that that's what was left to equal 1. So that's what was happening. You were just doing that as a mental step. So if you're dealt 1 card from a standard 52-card deck, find the probability that you are not dealt a diamond. So first of all, there's a lot of different ways we can do this problem. We can strictly look at what's not a diamond, but you could also just say, well, what's the probability of finding a diamond first? Because that might be easier to think about it that way. So the probability of selecting a diamond would be what? 13 out of 52, okay, which reduces to 1/4. So then the probability that you don't get a diamond, all you have to do is take 1/4 away from 1. So 1 minus 1/4 would be 3/4. So again, you don't have to necessarily do it this way, because you could figure out how many cards are not diamonds, but it's probably a lot easier to think about the fact that there are 13 diamonds than how many diamonds there are not, you know, to add up all those other groups of numbers. So your probability here is 3/4. Remember, another way you can look at it is how many suits are in a deck of cards? 4, and diamonds is just 1 out of those 4 suits. So you didn't even have to go with 13. You could have said, oh, 1 out of 4 suits is the probability of selecting a diamond. So therefore, 1 minus 1/4 is 3/4. Now, one thing I want to remind you guys is that you got to think about common denominators here when you're subtracting. And so let me start with this problem, being that it's a little easier. You can visualize this one a little bit better. But if we're doing 1 minus 1/4, so let me show you on paper here. If you're doing 1 minus 1/4, then that means that you needed a common denominator here. So 1 is always 1 over 1. And so to get a common denominator, we're just going to use 4. But whatever you multiply to the bottom, you always multiply to the top. So you have 4 over 4 minus 1/4. So I just want to show you a pattern with the number 1, and it can give you a shortcut later down the line. So then 4 minus 1 is 3 over that common denominator, 4. So if you're doing 1 minus 3/5, well, again, this is 1 over 1, so what's my common denominator? 5, and whatever you put on the bottom is always going to be the same number up top, because it's the number 1. So 5 over 5 minus 3/5 gives you just 5 minus 3, or 2/5. Okay, so notice what really happens is you're really just finding the same difference between the numerator and denominator in that second fraction. So notice 4 minus 1 is 3. Here, 5 minus 3 is 2. So if we did 1 minus 143 over 150, we don't really have to go through the process of finding 150 over 150. The shortcut is, it's just going to end up being 150 over here. So what's 150 minus 143? Bottom number minus the top number is 7. And then you keep the same denominator. Okay, so that's a good shortcut for you because it's always, this 1 is always going to just turn into the denominator. That's what the pattern's going to happen every time. I could have gone through the motions of changing this to 150 over 150, but why? Okay, learn the pattern and save some time there. So if I have 1 minus, 37 over 90, then what do I have to do to find my new numerator? 90 minus 37. Okay, which gives us 53, and then the denominator is still 90. Okay, so use that shortcut as we're doing these problems of 1 minus the probability. Okay, so back to our notes. Okay, mutually exclusive events. If it is impossible for events A and B to occur simultaneously, the events are said to be mutually exclusive events. So for example, if you're drawing one card, then it's impossible for that one card to be a king and a queen at the same time. So drawing a king or drawing a queen are mutually exclusive events. So if you're trying to find the probability of A or B that are mutually exclusive, then all you have to do is find the probability of A and add it to the probability of B. So for example, let's say you are drawing one card and you are trying to find the probability of selecting a king or a queen. Okay, key word in the problem is or. So not possible for you to draw a king and a queen at the same time. So if we wanted to find the probability of a king or a queen when you draw one card, well, because it's impossible for you to get a king or a queen at the same time, then this is the same as looking for the probability of a king and adding it to the probability of a queen. 4 out of 52, because there are 4 kings out of the deck of 52 cards. What's the probability of getting a queen? Also 4 out of 52. So now, adding these together, we get 8 out of 52, and now we want to reduce. So what do we get when we reduce that? Okay, 2 over 13 is correct. Okay, so the probability of selecting a king or a queen is 2 over 13. Okay, here's another one. If you roll a single die, what is the probability of rolling either a 4 or a 5? Now, what's the key word in this problem? Or. Good. So is it possible to roll a 4 and a 5 at the same time? No. So they are mutually exclusive events, which means we can use that formula. So we need to first realize that we can take the probability of 4 and add it to the probability of 5. What is the probability of rolling a 4? 1/6. And the probability of rolling a 5? Also 1/6. Okay, because there is one of those numbers on the 6-sided die. So then, adding these two numbers together, what do we get? 2/6, but always make sure you've reduced it to 1/3. Good. Okay, so any questions on an OR problem if the events are mutually exclusive? Okay, not mutually exclusive. What do you think that means? No, not the and, just not mutually exclusive. It can happen at the same time, right. So mutually exclusive means that they can't happen at the same time. Not mutually exclusive means they can happen at the same time, like drawing a card and getting a king or a heart. You can get a king and a heart at the same time. Okay, so you guys see the difference there? All right, so if they can happen at the same time, here's how the formula modifies. You're still going to add the probability of the first event plus the probability of the second event, but you also have to subtract the probability that they happen at the same time. So you have A and B, or you could say both if you want, the probability of both. All right, so when you have an OR problem, the key word is OR, you're always going to be adding your probabilities. The only modification to that means that you have to subtract what they have in common. All right, but think about this, that subtracting is still adding, it's adding a negative. Okay, so think of OR is always adding, to remember that. So, you know what, let me go back to this king or a heart so we can illustrate that one. So this time we want the probability of a king or a heart, which means we want to take the probability of selecting a king plus the probability of selecting a heart minus the probability of both, if you want to say that, okay? King and heart at the same time. All right, we already discussed that the probability of a king is 4 out of 52. What's the probability of a heart? Okay, 13 out of 52. And this time it's really helpful to keep that as a denominator of 52. Because remember, you're adding and you need a common denominator. Okay, so minus the probability of both. How many cards are both a king and a heart? Just one. The king of hearts is the only one that's a king and a heart at the same time. So 1 out of 52. All right, so adding, we get 4 plus 13 is 17, minus 1 is 16 over 52. So notice that this was the only time I did not want to reduce yet, not until we get to the very final answer. And so what does that reduce to? Start with a small number. If you've been dividing by 4 so far to reduce. Right, 4 goes into 16 4 times, and into 52 13, and then that's it. So 4 out of 13. It was the probability that you would get both of these at the same time. So the only time that you end up with a card that is a king and a heart is the king of hearts. So there's only one card that has both a heart on it and is also a king. And so that's where that last one came from. In a group of 50 students, 23 take math, 11 take psychology, and 7 take both math and psychology. If one student is selected at random, find the probability that the student takes math or psychology. So what is the key word here? Or, and then you have to ask yourself, is it possible for the student to take math and psychology at the same time? Yes, okay, so it's not mutually exclusive. That means you must subtract that part. All right, so working out our formula, the probability of math or psych means that you want to take the probability of math plus the probability of psych and subtract the probability that they're taking both math and psych at the same time. Okay, what is the probability that a student takes math? 23 over 50, good, because there are 23 total students who take math. What is the probability that the student takes psych? Okay, 11 over 50. Okay, and then the probability that they take both? 7. Yeah, I'm not putting it into the formula quite yet, just identifying each probability individually. Okay, so plugging it into the formula, then you have 23 over 50 plus 11 over 50 minus 7 over 50. Okay, so I got 27 over 50. Everybody agree? Does that reduce? Nope. So that is your final answer. Okay, so these were all problems that had a keyword of or, and then you had to ask yourself, if they could not happen at the same time, you're just adding the two probabilities together. If they can happen at the same time, then not only are you adding, but you're subtracting that possibility that they have both. Okay, the next thing we're going to look at is odds. There are two types of odds. There are odds in favor and there are odds against. So the odds in favor of E are found by taking the probability that E will occur over the probability that E will not occur. So if you don't have your handout, this is really the most important part, the formula right here, because it's what that is. The formula is what that says in words. Okay, so the odds in favor of E is P of E over P of not E. P of E over P of not E. Notice that not comes into play here. And we already discussed how to find the probability of something not happening. That 1 minus. Okay, so the odds against are found by taking the probability that something would not happen over the probability that it would happen. Okay, I heard the word reciprocal. Very good math word. Good. Some people just motioned that you were flipping it. Okay, other people said flip. Okay, but good. Good math word, reciprocal. All right, so these two things are just fractions that are reciprocals of each other. All right, so the odds against E can also be found by taking the reciprocal of the odds in favor of E. So if you've already found the odds in favor of something, you don't have to work out the formula again. Just flip your fraction over, find that reciprocal. And you want to find the odds of rolling a number less than 4. You know what, I'm going to change that to less than 3. Actually, no, I'll keep it. Less than 4. Okay. Sorry. All right, so single die roll, odds of rolling, okay, and I didn't say what kind of odds, did I? So let's say odds in favor of. So odds in favor of rolling a number less than 4. All right, so first of all, in order to find, so it says odds in favor is the probability of E over the probability of not E. Okay, that's your formula. So we have to first find the probability of a number less than 4. Okay, how many numbers are less than 4? 3 out of 6, so that reduces. Try again. 1/2, good. All right, so our numerator here is 1/2. All right, so then what's the probability of not a number less than 4? This is just 1 minus the probability that it did. So 1 minus 1/2 is also 1/2. Don't overthink this one. Okay, so the probability of getting a number that's not less than 4 is 1 minus the probability that it is less than 4. So 1 minus 1/2 is 1/2. So that goes in the denominator here. Okay, so the thing about this is that you've got a complex fraction. You have a fraction inside of another fraction. So what I want you to remember is that this fraction bar is also a division symbol. So this is the same as 1/2 divided by 1/2. And so this is, so you would have 1/2 times your reciprocal of 2 over 1. What happens to our 2's? Okay, but here's the thing. Even though your answer is 1, in an odds problem you need an answer that's in the form of a fraction. So it's 1 over 1. Okay, and I've run out of space here on my paper. Yeah. Okay, so it's 1 over 1 because the way that you're going to write your answer for odds is one of two ways. You're either going to write it in words that says the odds in favor of rolling a number less than 4 is 1, 2, 1. Okay, you've got this word 2 in between, and so your numerator 2, your denominator. That's how you always fill in your answers, numerator to denominator. The other way that they might ask you to write it is with a colon in between, and you'd say 1, colon, 1. Same order of your numbers, but then the colon means the word 2. So 1, 2, 1. Meaning for every number less than 4 that you roll, you can also roll a number greater, 4 or greater. It's 1 to 1. So it's, again, for every 1, 2, or 3 you can roll, you could also roll a 4, 5, or 6, 1 to 1. All right, let's do a different one. If you were finding the odds in favor of drawing a king from a standard deck. So the odds in favor, remember our formula, is the probability that that would happen, probability of a king, over the probability of not getting a king. So what is the probability of getting a king? Okay, 4 out of 52, or you can reduce that to what? No. 1 out of 13. Okay, so we'll use the reduced answer. And then the probability of not getting a king, okay, 12 out of 13 is correct. Because remember, you're doing the 1 minus 1 over 13. Okay, probability of something not happening is 1 minus the probability that it did. So 12 over 13. All right, so remember that this is a division problem, 1 over 13 divided by 12 over 13, or what you're really doing is the numerator multiplied by the reciprocal of the denominator. What happens to my 13s? They cancel, and so I get 1 over 12. So the odds in favor of a king is what? 1, 2, 12. Good. For every king that you can pick, there are 12 other cards that are not kings. That's really what it's telling you, what odds are telling you. All right, so what are the odds against? Okay, good. Odds against a king is 12 to 1 is correct, because remember that the odds against are just the reciprocal of that previous answer. So you're just flipping your numbers over. No need to work the formula all over again. Now, if it never asked you for the odds in favor and it asked you for the odds against, then you would use the correct formula for odds against, okay, putting the not on top and the probability that would happen on the bottom. Okay, so that's when you don't know the odds, but you know the probability of something. You're also going to take a look at problems when you know the odds, but you don't know the probability of it happening. So if the odds in favor of an event E are A to B, okay, we've gotten used to that pattern now, A to B, then the probability of the event is given by this formula. So if you have to go backwards and find what the probability of that would have been originally, you just take your A and put it over A plus B. Now it's very specific. Which odds do you need for this formula to work? In favor, right. You need the odds in favor for this particular formula. So if you're given the odds against, what do you have to do to those numbers first? Flip them, right, flip them. And then you can plug them into this formula. All right, so let's go look back at this problem for the king.